Okay, so I'm going to walk you through how to solve this two equations that you had on your warm-up. And just a reminder, last year you probably learned how to do this stuff already. But whenever you see decimals, you don't change the process. You continue to solve it just like we normally would. So I'm following along with the steps that are in the helpful hints portion of your activity. So the first thing I'm going to do is just draw this line, and the purpose for me doing that is so that whatever I do on this side, I also do on this side so that I can keep this statement true, this equal statement true. So my whole goal here is to isolate the variable because I want to know what x is. So I'm going to get all of the variables on one side first. Now I like to start with the variable with the smallest coefficient, and the purpose of that is just so that I do the same thing every time. So I'm going to start here, and I need to perform an inverse operation in order to get this x out of here. So the opposite of a negative is a positive, so I'm going to add 4.75x on both sides. Now notice I'm writing the x underneath my other x so I don't get confused. Now I just created a zero pair, so I'm circling this as if I zeroed it out. Now I didn't do anything to the 2.5, it stays positive, so I'm just going to bring it down. And then I add this together. So 5.25 plus 4.75 using my calculator gives me 10x. And then I bring down the 17.5 and we keep that subtraction or that negative sign. Now, once we got here, my second step says that I need to get all the constants on the other side. So if my variables are on my right side, I want my constants on the other. I'm going to add 17.5 to both sides. Again, I created a zero pair, so that's zeroed out. 10x, I didn't do anything to it, so I'm bringing it down, and then I add 2.5 plus 17.5. And when I put that into my calculator, I get 20. And then now that all my variables are on one side and my constants are on the other, I can divide or multiply to isolate the variable. So if a number and a letter are touching like this, there's an understood multiplication. The opposite of multiplying is dividing. So I'm going to divide both sides by 10. 10 divided by 10 gives me 1x, and so x is equal to 2. Okay, again, when we have decimals, don't freak out. It's the same exact process that we're going to follow. So now number 2. Again, the whole goal here is to isolate the variables so that I know what x is equal to. So the first thing that I want to do is get all the variables on one side. And again, it doesn't matter which one you start with. I like to start with the smallest variable just because that is easier to keep consistent. So I know negatives are smaller than positives, so I'm going to do the opposite of minus 20 or negative 27x, and that's positive 27x. So I'll add 27x on both sides. That created a zero pair. And then 27 plus 4x is 31x. I didn't do anything to this negative 13 here, so I bring it down. And I did do anything to this 2.5 here, so I bring that down as well. Now that I have all my variables over here on this left side, I need to get all my constants on the other. So I'm working on the same side as my variable to get this constant out of here. The opposite of subtracting 13 is adding 13. And anything I do on one side, I have to do on the other side. That creates a zero pair, and I bring down my 31x. And then that's equal to 15.5x. Now again, just because I have decimals or the number that's with the variable is bigger than my other number doesn't mean that I change any of the processes here. So 31x equals 15.5. I need to isolate the variable, and I do that by doing the opposite of what's being done here. 31 times x, the opposite of that is dividing. So I'll divide both sides by 31. 31 divided by 31 gives me 1. So I have 1x is equal to either 0.5 or 1/2, whichever way you want to write that there. And so that's how we solve multi-step equations.